finish the cycloid and the epicycloid?
Yes.
Good. So we're on to our final assignment, which is the hypocycloid. So on top of your page, you can write this for me. Hypo, Hypocycloid. Alright? Just a refresher. Cycloids are the path of a point that rolls across a floor, for example. Alright? Good. Epicycloid is the path of a point that rolls on another circle, for example. But what if we have a hypocycloid now? What would it be that path of that point? Let me give you a GIF, as you kids call it, a GIF. Here we go. Let's give you a GIF, hypocycloid. Here we go. Chirag, quickly describe this for me now. What would you describe the path of this point?
This is the path of a circle along the inside of another circle.
Exactly. So the path of a point of a circle that rolls on the inside of another circle. Excellent. So therefore, the curve you can predict would not be this, nor would it be this, but rather it would be like that. Alright? So let's firstly write the question that you would attempt. So here's your question for me. Let's quickly screen share it for you so you can write it on your paper. So draw the locus of a point, right? P on the periphery of a circle which rolls from the inside of a curved path. Take the diameter of the rolling circle as 50 and the radius of the directing circle as 75. Alright? So we have diameter of the rolling circle, which is, what's the diameter of the rolling circle?
50 millimeters.
So what will be the radius of that rolling circle?
25.
So that means small r, let me screen share, let me turn off the screen share now. Oh, I wasn't screen sharing. Oh, yes I am. One second, where's my screen share? I have no idea. 1 second. There we go. Good. So small r is equal to 25 millimeters, write that for me. Large r is equal to 50 millimeters. Alright, and I'm gonna call on one person to remind me of the formula to find the angle. The formula to find angle. Diksha, do you recall the formula? Diksha?
Yes, sir.
Yes, what was the formula to find the angle of a hypocycloid? Do you recall? Wouldn't it be r divided by large R multiplied by what? Come on guys, you should be revising. Anybody remember?
360?
360 degrees. Excellent, Sanjana. That's Sanjana, right?
Yes, sir.
Right, I'm getting good with the names. That's good. So R divided by large R multiplied by 360 degrees. If you didn't have this formula, please take it out for me. And let's fill in what we know. We know small r is 25. Let me show you on the screen quickly. Right? So we know the rolling circle is going to be 25. Right, here we go. So let's look at the calculation. So this is the rolling circle. That's the directing circle. And the formula, as we said before, is going to be now, the angle rather, is going to be 120 degrees, because 25 divided by 50 what's 25 divided by 50? Anybody? Oh, sorry, 25 divided by 75. Wow. 25 divided by 75. There we go. What's 25 divided by 75, everybody? Simplify this for me. 5 into 25 goes how many times? 5 times. 5 into 75 goes how many times?
15 times.
15 times? Okay, Google. What's 75 divided by 5?
The answer is 15.
15. Alright, so Google's a part of the class. So therefore, the simplified fraction is 5 divided by 15. So what's 5 times 360?
Sir, couldn't you simplify that more?
Can you repeat that for me?
Couldn't you simplify that more into like a third?
You could. 5 into 5 goes 1, 5 into 15 goes 3. So therefore, what is 360 divided by 3? Okay, Google? What is 360 divided by 3?
The answer is 120.
120. Thank you, Google, because my students don't like to talk. So 120 degrees is going to be the angle of our path. Good?
Wait, sir, what's the formula again?
I'm right up here. R, small r, divided by large R, right? Multiplied by 360.
Wait, what are we finding in this formula?
The angle of the curve. Let me screen share. Look at this for me now. The angle of this curve right here. Right here. This curvature right here. So before we can begin our drawing, we must know the angle, and we just found it is 120 degrees. Alright? Everybody clear? So we're going to say O is equal to 120 degrees. O is equal to 120 degrees. Now we have all the information we need to begin drawing. So I'm going to erase the board in 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's quickly begin. Alright. The very first thing I need to do is to draw a horizontal line. Right? And the distance of this horizontal line can be told by the entire circumference of the circle. So what's the formula for the circumference of a circle? Anybody?
20.
1 second, let me show you. To find this distance, that would be what?
That would be
Anybody?
2 pi r?
2 pi r or pi d. Right? But you have to keep in mind that that was only used for the cycloid. Right? That was only used for the cycloid. So in a hypocycloid, right? This distance, what would it be? Let me see if I can find the quick screenshot. You can find that distance, right, by drawing a 120 degree line. So you might not know the distance where it stops, but you can just quickly draw a 120-degree angle line. Quickly do that for me. Call this 120 degrees. So even though we don't know the distance of this line going across, as long as we can find the angled line, then we can get a curve to know the point over here. So here's what we're going to do. I want you from this point to measure off some distances. The very first distance you're going to measure off is 75 millimeters. Go back. Alright? Very first distance, so from here, you open your compass to 75 millimeters and scribe an arc. Let's say it's about here. Alright, so for those who are watching the video, I just showed you on the screen. So this is a distance of C, O, and let's say it is 75 millimeters. Let me use another color so you won't be confused. 75 millimeters. Everybody clear so far?
Yes, sir.
Here's the interesting thing though. If I want a circle to roll on the inside of another circle, who's that? Let me see who's late. Alright, bulging. Alright, camera's on for me, dimple camera on. So camera on. What do they call it? Tongue twister. Camera on, camera. So if I want to know the distance to when the circle rolls on the inside of the directing circle, here's what I'm going to do. Right? I am going to go 25 millimeters from the point I just made earlier. I'm going to go 25 millimeters from the 75 point line. And let's say it stops about here. Right? 25 millimeters. There we go. Everybody clear on that? I'm going to call this P. So there's a difference between the hypocycloid and the epicycloid. Because in the epicycloid, you were taught to go 50 millimeters. But now we're only going to go half. Right? Because we want this center point to be under the inside of the next circle. So, once you get that center point, you're going to draw your circle. Let me draw my circle of radius 25. There I go. Okay? And now, what I'm going to do, I'm going to extend this line throughout. I'm going to extend the line throughout, and here's what happens. Now I can use this point as my curve to find out the distance of the entire line. Alright? There I go. There you go. You're going to open your compass from O all the way to the very top and then draw your arc coming downwards to form your line. Let's say that mine would be, for example, here. Everybody understand that? There you go. We're going to call that point Q. So there's a difference between a hypocycloid and the epicycloid. Because with the epicycloid, wasn't this point all the way up here? Because now we're inside of this circle. before we were on the outside up here. Brilliant. Now the next thing you're going to do now, you're going to divide your circle into 8 parts. Alright? Divide it into 8 parts. Quickly. Just use the color pink to divide it into 8 parts. I'm going to go vertically upwards, downwards, going across. Alright. And from the center line now, we're going to start to bisect this entire curve. From the center line, from O, we're going to draw this curve going beyond. And from each quadrant where you have the points inside, you're going to do the same process.
Sir, you're going a bit fast.
Can you repeat that for me?
You're going a bit fast.
Alright, let me pause for a second. Where's everybody?
I'm dividing the circle right now.
Alright, so while you're dividing it, let me just quickly number it. So you might realize that the numbering now is different based on where P is. So quickly identify P for me. Let me show you where P is. And based on where P is, that's where we're going to start to number. Here is P, right? So directly after P, we're going to start numbering 1. Everyone see that? So this is the only exception where we start to number clockwise. Alright, before when we had P down here, we had to number 1 going the opposite direction. So when we're doing the hypocycloid, our numbering starts from the top here, P.
Sir, are we dividing it by eight parts? The circle.
Tell you what, I want you guys to try 12. Thank you for reminding me. We've been doing 8 so far. Let's try 12 this time. Okay?
How do you do those again? Like divide the circle and stuff?
Alright, 1 second. Let me erase my divisions. 1 second. Alright, so the most important thing you must do first is to get your circle in a quadrant, which is 4 sections. Alright, so what you're going to do for make sure where your center point is, you're going to draw a vertical and a horizontal line. So here's a vertical line, the vertical line going upwards, and your horizontal line going across. Alright?
Sir, do you just choose random point?
No, there's a specific method to this, where you're going to open your compass, right? And scribe an arc above and below. Do you remember that step? Or am I going to go through it again?
Please, sir.
Alright, sure. Let me just quickly play a video for you. 1 second. So let me just pause